But if gravity bends space-time, we should be able to see subtle ripples in the image. It is a pretty weird coincidence that the moon and the sun appear the same size in the sky, but the fact that this is true allowed us to discover the time-bendy stuff that you saw in the movie Interstellar. Einstein had this theory that if you were in an elevator and the elevator was accelerating up, you wouldn't be able to tell whether you were in an elevator that was accelerating up or whether you were just sitting on a planet that had that same amount of gravitational acceleration. This, in general relativity, is called the equivalence principle. Moving, accelerating, specifically accelerating through space, and being in gravity are physically identical, according to Einstein. If you're not familiar with the movie Interstellar, they go to a planet that has really, really, really strong gravity, and time effectively slows down for them relative to other people. He is chilling on high gravity planet, and his daughter ages like 30 years while he's just down on this planet for like a couple of hours. That's exaggerated, but it is scientifically accurate. Gravity bends space-time, and if gravity bends space-time, then it will also bend light rays as light rays are moving through that bent space-time. Throughout the course of the year, as the Earth orbits the sun, what we see behind the sun changes. But if gravity bends space-time, we should be able to see subtle ripples in the image as we orbit the sun. And we would see that, but the problem is that the sun is really bright, and that squiggly area is just really close to the sun's edge. But if the moon is blocking out most of the light from the sun, then you can see in detail the light from stars passing right next to the edge of the sun. So in 1919, astronomers went to Africa and Brazil, watched the solar eclipse during totality, and were able to take detailed measurements of how the sun's gravity was bending the light rays around it.